Hi, this is Mohammed and my teammate is Joma Desai. Right now, I'm going to explain the ICP 9 of the Python deep learning assignment. So, firstly, this is the source code given by the professor. Then I was importing all the required libraries and then loading the MNIST data where I was getting the training and the testing data. So I was randomly putting the one of the data, and then here we'll be converting this image shape. So we'll be having 28 by 28 into 784 dimensional. So and then by using the numpy dot np dot prod, and then I was finally was printing the shapes of this training and testing data. So 600 images, and then this is the 784 the columnar data. Like we'll be converting 28 to 28 by 20 dimension to 784, and then was converting the data into from integer to float to scale the data. So here I'll be scaling the data by dividing by 255. So actually the integer data, it will be like it will be in the range 0 to 255. So by convert, so here we'll be doing the scaling in the sense, so here the scaling will learn and mm, understand the problem more accurately and give the better results. So that's why we'll be scaling the data. So we will be simply, you can say, we will be reducing the mm, size of the images. Okay, and then I was converting these images from the integer to the one hot to the encoding by using one hot encoding. So the model will be created by using the sequential, and then using the activation function, will be executing the model until predicting the result. So this is the actual code given to the professor now. So here from here, this is the actual part of the implementation I was done. So the first task is like we need to change the number of units from the actual code given by using the activation functions like a tanh or relu, and we need to report the accuracy. So firstly, what I'll be doing, I will be implementing this code by adding the activation function tanh. So firstly, I was creating the object for the sequential like a model, and then I was then adding the three-dimensional layers here. So actually, and the activation function I use this tanh. So yeah, first they will be getting the input data, and then I had used the dense layer with 512, and then this the output we got from this input layer will be passed to the next layer. So the same activation function I use tanh, and then here it will be having 250 layers. Similarly, the next one 128, and then 64, and then finally it will be having the 10 layers because softmax is used for the labels which are having a multi-class. So here my output layer will be like a 0 to 9, and so that's why it's a multi-class. So that way I'll be using the activation function softmax, and then here I will be compiling the model, where the optimizer I use the RMS and prop, and then last function I use category crossing to find the metrics accuracy. And finally I was fitting the model and executing. So after executing the model, here you can see after 20 iterations, here you can see the loss in accuracy for both in the validation, I mean testing data. So and also I'm evaluating on the test data. So here you can see the accuracy is 97%, and then the loss is 10%. This is for the TANF. And similarly, I was doing the same thing for sigmoid. So actually this can perform in the different notebooks. Like for one notebook I'll be using TANF, the other notebook I'll be using sigmoid. So instead of to show everything, every output the same way, I had just put the layers like this, but I was executed in different notebooks. So similarly I had done the same for the by using the activation from sigmoid. So after we got the accuracy 97% here also, and then finally we'll be using the ReLU, the same code just by changing the activation function to ReLU. Software is compiling, executing, and then finally evaluating the model. Will be getting the accuracy 98%. So here you can see the ReLU has the accuracy 98%, and then tanh has the 97, sigmoid has 97. So here the ReLU is having a more accuracy function, more accurate value, because so it as it overcomes the vanishing gradient. So where tanh or sigmoid gives error like a vanishing gradient, where I had explained clearly and also had given the link. So then next, I need to plot the accuracy and loss function for both the training and the testing data. So here first I was plotting the accurate function for both the training and testing. And so with the approach on the x-axis and the accuracy on the y-axis. So here you can see there's no much difference for the accurate values, so no overfitting and underfitting. Similarly, for the loss or loss loss data, also there is no much difference. So here the loss is always decreasing. So here like it's like somewhat increasing and decreasing. So not much difference. And then here what I'll be doing, the same layer model, I was just converting the same model from sequential to functional API. So here you can see, so I had imported the libraries which need to implement the functional API. So similarly, I had added an input layer will be stored as the I, and then this layer will be sent as the input to the next layer, like 256. The output of this input layer will be sent as the input to the next layer for the two, which is having 256 filters. Similarly, the same thing. And then finally, after compiling and executing the model, I got the accuracy is 97%. So evaluating model, I got like 97%. There's not much difference. So when I use the sequence model, it is 98, but now it is 97%. And then finally, I need to plot the one image from the test data, and then I need to predict the model from that image by using those test data. So here you can see I was randomly taking the index like is 130. So I was printing the image from the test data. It is here you can see the 6, and then finally I was predicting the image from the model. So this can be done by using the function model dot predict. So here you can see from the test data I got the prediction of the image is 6. So the class is 6. So exactly whatever the model is showing, it is matching exactly. And then finally, the third task is like I need to implement the. So I need to change the code by using without scaling the data. So we actually what we had done, we had scaled the data where I told that by using the scaling the data, the model will learn and understand the problem and do the accurate like best results. Like so, just like converting the larger images to the smaller ones. So for this task, what I'll be doing, we shouldn't be using the scaling up. So this rest is the same code. So here you can see one of the image from the test train data. So actually, then without scaling the data, actually it will be in that range 0 to 255. So here you can see the data. And then the same thing, same thing has been implemented for implementing the model. The same code I had used, like the activation function is value, then compiling and executing. So after executing the model, I got the accuracy of 97%. So when scaling the data, I got a more accurate, like 98%. But without using the scaling approach, it dropped to 97%. Like if multiple runs, it got changed to 97. So actually, it will be like more. It will drop to more percentage, like 95, 92. But multiple drops, multiple execution of the program, so it is like 97 percentage. Then the next one, like the bonus function, bonus problem. So the same thing, So yeah, so I had commented this one from the source code. So the one hot encoding, changing the integer values to one hot encoder. So actually, what I need to do, the task is like I need to change the from loss function to sparse categorical like cross entropy. So here, what I'll be doing is actually previously I did only categorical cross entropy, but here I need to change to sparse categorical cross entropy. So before, when I use this function, when I executed the model and I compiled and finally executed the model, I got an error like this. So expected dimension of one got 10. So actually, what it happened is when we used like categorical cross entropy, so the data actually, so what it will be happening like so the exact result we'll be getting. But when we use the sparse categorical, so it will be throwing the error like this. So it is expecting the dimension of one. So what I will be doing here, I will be converting them. So I will be commenting this one hot encoder. So after executing this, I had explained it clearly here. So by removing the non-hot encoder, so I will be getting the output. So here you can see, so if you're using like categorical cross entropy, so you need to do one hot encoder. And if you are not using like categorical cross entropy, but you're using sparse categorical cross entropy, you can directly inject the labels. So yeah, that's what the difference. Then the next one is like what the NumPy method to print the correct class from the model prediction. So after executing, so the prediction.argmax model.predict is method to predict the exact result from the test data. Then NumPy function I use argmax. So thank you.